Inner product of V1 and V1. 1 plus 4 is 5. So V2 is U2 8 1 minus 6 minus okay, let's first do the inner product of U3 V2 to make our life easy. Yeah, so inner product of U2 and V1, that is inner product of U2 and U1, that is U2 and U1, 8 plus 2, that is 10. So V2 is U2 8 1 minus 6 minus 10. Norm of V1 squared is 5. V1 is U1. So that is 8 1 minus 6 minus 2 1 2 0. That is, yeah, 8 minus 2, that is 6. 1 minus 4 minus 3 minus 6. So norm of V2, inner product squared, na? 6 6 36, 36 plus 9 plus 36, 81. Okay, then what is V3? V3 is U3 001 minus, oh, I forgot to find U3 V2. Let's do this here. This is very difficult to do it on iPad. U3 V2. Come on, U3 V2, U3 V2. Where is V2? V2 is here. This with U2. Okay, let's see. 48 minus 3, 45 plus 36. 45 plus 36, 81. And I also have to find U3 V1. No. U3 V. Oh, no. Sorry. I was looking at the wrong thing. U3 V1. U3 V2. U3 is 001 and V2 is this. So that is very simple. Minus 6. U3 V1. Yeah, that's interesting. U3 V1. V1 is this guy. So 6 minus 6, 0. So U3 V2, that is minus 6 upon norm of V2 squared. This is norm of V2 squared, actually. Norm of V2 squared 81. V2, 6 minus 3 is minus 6. Minus U3 V1, that is 0. Okay. So this gives me what? So this gives me, let's see, 36 upon 81, comma, minus 18 upon 81, 1 minus 36 upon 81, so 45 upon 81. So that is, I can write this as 1 upon 9. Yeah, so 4 upon 9 minus 2 upon 9, 5 upon 9. 9 is a common factor. So that is 1 upon 9, 4 minus 2, 5. That is V3. My goodness, I give you such a simple problem. Huh? And you guys were screaming. You guys were screaming, oh, it was so long, it was so long. No, 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 no. On the final, I'm not going to give you such an easy problem. Excuse me, excuse me. Then my students will get upset with me. They will say, Professor gave us such a simple exam. Our professor insulted us, right?
No, Professor, please give us easy one. We like to do the calculation, but
Oh, really? This
but
is
when
so easy. Let's see.
no, if it is difficult, we get lost.
16 plus 4 plus 25 upon 81. So that is 45 upon 81. And so V3 will be square root of this. So actually this is 5 by 9. So this is square root of 5 upon 9. So now you normalize, orthonormalize it. Answer Q1, V1 upon norm of V1. So V1 was what? V1 was 120. Norm of V1 is here, is square root of 5. 120 that's one thing. Q2 is V2 upon norm of V2. And norm of V2 is, so norm of V2 is 9. And V2 is what? So 6 minus 3 is minus 6 upon 9. 6 minus 3 minus 6 upon 9. I can write this as 2 minus 1 minus 2, 1/3. And Q3 is V3 upon norm of V3. So V3, this is V3. 1 upon 9, 4 minus 2, 5. Upon norm of V3, that is upon square root of 5 upon square root of 9. So square root of 9 upon square root of 5. So that will give me this is square root of 9. So that is 1 upon 3 root 5, 4 minus 2, 5. That's the answer. I want to do one more Gram-Schmidt because of a different type, with an integral type actually. Because so this is the question I gave you on the second exam on R3 using the standard Euclidean product. But on the exam, on the final, I will give you a problem like this. Yeah. So consider this set of all continuous functions minus 1 to 1. And for PQ in this space, define the inner product P comma Q, inner product, to be integral minus 1 to 1 Px Qx dx. So consider the basis. One x squared. Use Gram-Schmidt to to orthonormalize it. Okay, so we start like this. So u1 is 1, u2 is x, u3 is x squared. So v1 is equal to, you must know this thoroughly, right? This is your exam. v1 is u1. So that is e1, 1. So then what is the norm of v1? It is the inner product of v1 and v1. Norm of inner product v1 squared, inner product of v1, v1. So that is, inner product is defined like this. So minus 1 to 1 dx. So that is x between minus 1 and 1. So that is 2. So that means norm of v1 is square root of 2. Next, v2 is, how will you do that? Tell me, quick. v2 means you start with u2. u2 minus inner product u2 v1 upon norm of v1 squared v1. Is that right? u2 v1?
Yes.
Inner product u2 v1 and norm v1 is v1, right? Right. So what is the inner product of u2 v1? So that will be integral minus 1 to 1. u2 is x and v1 is 1. So it's x dx. So that is x squared upon 2 so 1 upon 2 minus 1 upon 2. So that is 0. So that makes your life very simple. v2 is u2. And that is u2 is x. So norm of v2 squared is inner product v2. So that is integral minus 1 to 1 x times x squared dx. So that is x cubed by 3. So that is 1/3 minus 1/3. So norm of v2 is square root of 2 upon 3. v3 is u3 minus inner product. So u3 v1, u3 v2 upon norm of v2 squared v2 minus inner product u3 v1 norm of v1 squared v1. So inner product u3 v2 is integral minus 1 to 1 u3. u3 is, where is u3? u3 is x squared and v2 is x. So x to the 4. No, x squared and x cubed. Let's see, u3 is x squared. And yeah, that's right. So that is 1/4 minus 1/4, so that is 0. So then your life is so simple there. u3 v1 is minus 1 to 1. u3 is x squared. v1 is 1. So that is x squared. So that is 2/3. So what is v3? u3, that is x squared. Now u3 v2, that's out, minus u3 v1 is 2/3 upon norm of v1 squared. Norm v1 squared is 2/3. Very nice. And v1 is just 1. v1 is 1, isn't it? v1 is 1. Yeah. So that is x squared minus 1. So what is oh no, that's okay. No, I have a question here. Norm v2, no? Oh, v2 square, u3 v2 u3 is what? No, wait. u3 is x squared and v2 is x. Let's check this carefully. This
Professor,
is
the V2.
wait, just a minute. This is correct. Yeah, now what is your question?
The V1 square should be 2, not 2/3, isn't it?
No, wait.
V1 square you wrote over there is 2, but at the answer you wrote 2/3 over 2/3. It should be 2 over
Okay, I'm coming to that. So v1 is this. Okay, thank you. And v2 is, so let me first check this. This is correct. So v2 is, so this is correct. So norm of v2 squared is, this is correct. This is correct. Okay. And now my friend's question here. Now, yes, you are absolutely correct. I saw norm of v2. You're perfectly correct. So you're perfectly correct. u3 v1 is 2/3 over norm of v1 squared, and norm of v1 squared I did not even see because it was hiding. Norm of v1 squared is 2, perfectly correct. So that is x squared minus 1/3. Now I'm happy, correct. This is correct. And now this is not the end of the game. So q1 is v1 upon norm of v1. So v1 was 1, norm of v1 is root 2, so 1 upon root 2. q2 is v2 upon norm of v2. v2 is x upon norm of v2. Norm of v2 is root 2 upon 3. Good. And q3, but that needs a little work. It is v3 upon norm of v3. We still haven't done norm of v3. So norm of v3 squared is inner product v3. And that is integral minus 1 to 1 x squared minus 1/3 times x squared minus 1 squared dx. So that is integral minus 1 to 1 x to the 4 minus 2x squared upon 3 plus 1 upon 9 dx. That is x to the 5 by 5 minus 2x to the 4 upon 4 3 is a 12 plus x upon 9. One upon 5 minus 1 upon 6 plus 1 upon 9 minus 1 upon 5 minus,
Professor,
wait,
isn't it negative 2x to the third over
What?
9?
no, what?
X to the 5.
Here we are doing it correct. Wait, we are doing it correct. Don't distract me now. Wait. And then I will explain if you have any questions. So this is 1/5 minus 1/6 plus 1/9 plus 1 upon 5 plus 1 upon 6 plus 1 upon 9. So this will give you 2 upon 5 plus 2 upon 9, 45, 9 to 18 plus 10, 28 upon 45. Okay, so that is sorry, what was your
When
question?
you do the antiderivative of 2x squared over 3, you make a mistake. You wrote 4.
I made a mistake. No, okay, wait. Maybe that was he was saying. Wait.
Yes. X cubed to the 9.
Yeah. Tuck. Okay. Yeah, you see, it's very difficult to do these things on iPad. When you do this on a chalkboard, I'm desperately waiting to go back to campus. 2/3 x cubed by 3. So this will become x cubed by 9, right?
Yeah, yes, Professor.
2/3 x cubed by 3, that is perfectly correct. And now that is equal to 1/5 minus 2 by 9 plus 1 upon 9 minus 1/5 plus 2 upon 9 minus 1 upon 9, and that is 1/5 okay. Ooh, that's interesting. Nothing cancels. Yeah, that's okay. 2 upon 5 minus 4 plus 2 minus 2 upon 9. 45. 18 minus 10. 8 upon 45. Okay, and what is my V3? What was my V3? V3 was, where's V3? X squared minus 1/3. So Q3, did I do this correct? Can everybody check? Minus 2/3 x cubed by 3 is 2/9. That is absolutely correct. 1 upon 5 minus 2 by 9 plus 1 upon 9 minus 1 upon 5. This becomes minus plus. Okay. This plus minus plus, yes. 2 by 5 minus 4 plus 2, yes. 9 2s 18 minus 5, yes, that's okay. Okay, so Q3 is what? What's Q3? V3 upon norm V3, na? V3 upon norm V3. So V3 is x squared minus 1/3 upon norm of this. So that is square root of 8 upon 45. So you can do it this way. 3x squared minus 1 upon 3. This is 2 root 2 over is 5 times 9. 3 square root of 5. Yeah, square root of 45 is 5 times 9, so 3 and square root of 5. You see the beautiful thing? This cancels. So you're left with square root of 5 upon 2 root 2, 3x squared minus 1. That completes the problem. Okay, that is Gram-Schmidt. I told you, so let me take some, I have some problems for you, which I will go through so that just for fun. Say, for example, this one. Let U and V be orthogonal vectors. If U plus V and U minus V are orthogonal, show that norm of U is norm of V. Okay, really do we need this? Okay, norm of U is norm of V. Okay, so U perpendicular to V implies inner product of U and V is 0. Inner product of U plus V and U minus V is 0 because that implies to distribute U minus UV plus VU minus VV, and that's 0. But UV, inner product UV is 0, inner product VU therefore is 0. That implies norm of U squared is equal to norm of V squared. That implies norm of U is equal to norm of V. Take another problem like this. I think we did this in class, but see, just for fun. Yeah, I'm going to write it down. Just a minute. Prove that, you will see the screen, right? Norm of U is equal to norm of V if and only if, this is a good one, U plus V is perpendicular to U minus V. If and only if. So let's do it this way. Suppose U plus V is perpendicular to U minus V. Implies inner product U plus V, U minus V. So first let us calculate the inner product. That's better. without doing if and only if. Inner product u plus v, u minus v is inner product u plus v u minus uv minus vv. So that is norm of u squared, but this cancels out, minus norm of v squared. Okay, now it's so simple. So u plus v is perpendicular to u minus v if and only if inner product u plus v, u minus v is 0. If and only if inner norm u squared minus norm v squared is 0. If and only if norm u squared is equal to norm v squared. If and only if norm u is equal to norm v. Okay? Who will tell me that, wait, I will give you time to write. Yeah. All you need to know about orthogonal matrices is this. A square matrix is orthogonal. If and only if A transpose is A inverse, isn't it? A inverse is equal to A transpose. That's all you need to know. And that means what? Equivalently, A inverse is A transpose, and that is I. So a matrix A is orthogonal. A is orthogonal. This is the only thing for your exam. This is the only thing that you need to know for your exam. If and only if A inverse is A transpose, if and only if A transpose is the identity matrix. That is all that you need to know. Next, let us do a problem on find the eigenvalues, eigenvectors. So listen guys, tell me, do you want to diagonalize anything?
No, never.
Did you find saying no, never? Huh? I'm going to put a diagonalizing problem on the exam. Wait.
That'll be extra points, I guess.
No. Find the eigenvalues and eigenvectors for, and so let's take the matrix that I gave you on the second exam. So you will see the screen soon. Okay, so what were the eigenvectors? So you see, what is lambda I? Lambda 0, 0, 0, lambda 0, 0, 0, lambda. So the characteristic equation is determinant of A minus lambda I is 0. So that implies determinant 1 minus lambda 3, 3, minus 3, minus 5 minus lambda minus 3, 3, 3, 1 minus lambda, 0. So then let us do this carefully. 1 minus lambda minus 5 minus lambda, 1 minus lambda, minus 9, minus 3 times 1 minus lambda plus 9 plus 3 minus 9 minus 3 minus 5 minus lambda. Okay, that's 0. So let us do this thing carefully. 1 minus lambda. Okay, got it. So what do I have? What do I have? Minus, so lambda squared minus lambda squared minus lambda plus 5 lambda, 5 minus lambda plus 4 lambda minus 4 lambda minus 5 plus 9. 9 minus 5 is 4 minus 4. I can see what is happening. Minus 3 minus 3, so 3 lambda plus 6 plus 3 3 lambda 15 minus 6 plus 6. Okay, that's 0. So you see there's a minus 3 times that plus 3 times that cancels out. And there is a minus which we can take out, so minus goes out. 1 minus lambda, and this is lambda squared plus 4 lambda plus 4 is 0. So lambda minus 1, lambda minus 2 squared plus 2 squared is 0. So the eigenvalues are 1 minus 2 minus 2. Repeated root, there's 2 repeated roots. 1 minus 2 minus 2. Now the eigenvectors, for eigenvectors, Ax is lambda x. A is 1, 3, 3, minus 3, minus 5, minus 3, 3, 3, 1. And here is your x1, x2, x3, lambda x. So that is lambda x1, lambda x2, lambda x3. Okay, so when lambda equal to 1, what do you get? You get x1 plus 3x2 plus 3x3 is equal to x1 minus 3x1 minus 5x2 minus 3x3 3x1 plus 3x2 plus x3 is x3. Okay, so what do you get from here? From here you get x1 plus x2 is 0. So x2 is equal to minus x1. And from here you get x2 plus x3 is 0. So x3 is minus x2. So x3 is equal to minus x2. that is minus of minus x1, so that is x1. Wonderful. So the corresponding, for lambda equal to 1, the eigenvectors are x1, x2, x3. No, x1, x2 is minus x1, x3 is x1. So x1, 1 minus 1, 1, but x1 is any scalar. Okay. Now, when you have a repeated roots, that is minus 2. So then what happens? Then this happens: x1 plus 3x2 plus 3x3 is equal to minus 2x1 minus 3x1 minus 5x2 minus 3x3 is minus 2x2, 3x1 plus 3x2 plus x3 is minus 2x3. Okay, So this gives you what? 3x1 plus 3x2 plus 3x3 is 0. So you will always get x1 plus x2 plus x3 is 0. This is interesting. And how do you manage that? How do you manage this? How do you manage this? This is very nice. So that means x2 plus x3 is equal to minus x1. So your x1 is free, therefore. So you write it this way: x1, x2, x3. So this will be, your x1 is free, all right. So x1 is free. Okay. Okay, so this is what I will do. Same thing. It's let me break it in terms of, so x3 is minus x1 minus x2. So this is x2 and this is minus x1 minus x2. So this will give me what? So this will give me what? This is x1, 1, 0, minus 1, plus x2, 0, 1, minus 1. Am I right? x1 is x1. x1 times 0 plus x2. So x1, x2. Minus x1, minus x2. So the eigenvectors are, so there you go. These are the eigenvectors. These are the eigenvectors. So x1 and x2 are any scalars. These are the, so the eigenvectors for the, so yeah, these are the eigenvectors. For lambda equal to minus 2. That's it. So actually, when I asked you to diagonalize it, the matrix P that diagonalizes this was like that, was like this. You see, 1 minus 1, 1. 1 minus 1, 1. 1, 0 minus 1. 0, 1 minus 1. And then when you do P inverse AP, actually I did my calculations here. Where am I? Yeah, your P inverse AP, it depends on how you write, but that's not a problem. It will be exactly this, not exactly, this is the kind of thing. Or the diagonal elements will be 1 minus 2 minus 2, but it may repeat, it may be different, it may be maybe something like this, say, so it may be the diagonal elements 1 minus 2 minus 2, or minus 2 minus 2 1, like this. So that was the question that I asked. Very good. Let me see. Do I have any more? Okay, so
Professor,
yes.
is it still right if I got for the second column I got negative 110?
No, that's fine. As long as when you do when you diagonalize it, when you get P inverse AP, your diagonal element will be either 1 minus 2 minus 2 or minus 2 minus 2 1, like that.
Okay, thank you.
Okay. Okay. Yeah, definitely. There can be variants in the different ways. Yeah. Okay. Okay. Now, what am I going to say? Just give me a little time because I want to double check one thing. Or double check means final check one thing. So nobody is going to travel, right, during the holidays, during the vacation?
No,
Perhaps you-
Professor.
Huh?
Staying home. No.
Yeah, no. How many of you are going to Bangladesh?
Oh no. Now?
Oh, no.
Are you
I have-
going to Bangladesh, Professor?
Huh? Me?
Are you from Bangladesh?
No, I'm from Calcutta.
Actually, I have 3 years old. I don't even go out for grocery.
By the way, all of you know that they are going to, so they are going to close all indoor dining from Monday.
Again?
Yes, this is today's announcement. For that governor's announcement.
I think it's everything is number is increasing in New York. That's why.
Yes.
So when
Yes,
the
this is-
hospital fills up, I think they're going to do another lockdown like California.
Not a lockdown, but this is kind of the kind of
It's
half
better.
lockdown.
Carb side pickup is better than the indoor dining.
Yeah. Yeah, because I was eating out too much. I have to stop.
You have to order.
I was in upstate New York during the peak time. I just recently moved to New York City, so I have no idea.
Oh, so I gave you those. Okay, so 8 questions I told you, right?
So gave us 8 questions
Yeah.
yesterday and today.
Why don't we make it 10? Are you happy?
Oh no, Professor, it takes too much time to do the calculation. Please, no. Please, no.
Because you are stuck at home getting bored, so why not?
Oh, brain doesn't work anymore since we are stuck in home.
Oh, really?
It's depressing, Professor. Even though it's some winter, we don't go that much outside, but still it's depressing.
Yes, it's very depressing. That's absolutely correct. And that's why I want to cheer you up with giving you 10 problems. So
How
that
about you just give us extra 10 points for free?
Yeah, that
Cheer
would be
us up.
great. That would be great. The holiday gift.
Okay, now listen. So this is the final. But as I said, please come. All of you should come. Please
10
come.
minutes early.
Not 10 minutes. Come at 1:30 p.m. I will be ready at 1:30 p.m. So I am going to send you the exam at 1:30. So then there is a time lag always, I'm saying, the 7-8 minutes, so that you can really start straight at 1:45. If you get it before 1:45, who cares? You start. But your time is till 3:45. Exams to be turned in, exams to be turned in, to be returned will be by 4 p.m. So you have time to write till 3:45. So by 4 p.m. That same day, of course. Don't say that. Yeah, no duplicates, no, those things not allowed. Okay, now let me check. I sent you this yesterday. So let me check this. 31 room, yes. Okay, so let's see. So yesterday was 10th, right? Good. So I'm going to call and you just tell me. So one problem on Grab-Schmidt. One problem on find the eigenvalues, eigenvectors. I will not ask you for diagonalization. 2 questions on linear transformation, exactly the kind of things. One will be a theorem and one will be a problem, what we did yesterday. One question on eigenvalues, eigenvectors, which I did yesterday. Orthogonal matrix, you just need the definition. When I say 2 questions fun, there is no fun actually. It's just on inner product space. It's on an inner product space, and all you need to know is, so for example, what's the angle? Suppose I say what's the angle between 2 vectors. So cosine theta is inner product P comma Q over norm of P, norm of Q. That's one thing. Okay, very important. What is your review? Step 1, review everything of December 10. Step 2, review everything of December 11. If you really do this, review means redo the problems and go over all these things. If you do this, then you're all set. Because I have the exam read, basically I've written down the exam, so then you will be all set. Any questions now?
Professor, for the orthogonal matrix question, you say
Yeah.
it's going to be definition, so it's theorem?
No, it will not. I never said that it will be definition. All I said that if you know the definition, you will be able to do the problem.
Can you give us an example of
No.
orthogonal matrix?
No,
Problem?
no. What should I give you an example? Why should I give you an example? What kind of a question? Say for example, okay, say for example, if I say this, so 0, 1, just a minute, 1 upon root 2, 1, 0, 0, 0, 0, 1 upon root 2. Determine whether the matrix is orthogonal. Okay, so the A transpose is, instead of going for the inverse, you write down the transpose. A transpose is what? 0, 1, 1 by root 2, 1, 0, 0, 0, 0, 1 upon root 2. So A transpose is what? So that is 1. Yeah, 0. Zero plus oh, I see. 1. So it is not orthogonal. You can, because it's not identity. So, but let's do this. Zero, 0, 0, 1, 0, 0, 0, 1, 0, 1. So it's not the identity matrix. So it's not orthogonal. So A is not orthogonal. So I cannot say anything more than this. All you need to know will be the definition. That's what I told you. That's not a good idea of trying to be spoon-fed. Hello? No spoon-feeding.
I have a question.
Yes.
For the linear transformation, you said there's going to be one theorem and one problem, right?
Exactly like what we discussed yesterday.
Okay, thank you.
Exactly. I not only one theorem, I gave you 2 theorems, right? And one of them.
Okay, thank you.
Exactly one of them, and exactly the kind of problem I did yesterday. Then there cannot be anything fancy. There I cannot make up anything. I cannot cook up anything.
Professor,
Yes.
you said there's going to be 2 questions on like the fun. So are those
What's fun? There is no fun.
Yeah, but are those going to be 2 questions on the angle between, or is it just one?
No, I didn't say angle between. I said that. Okay. For those 2 questions, if you know the definition of angle, if you know inner product, and you are doing it, Grant Smith, you are doing it. So you know how to find inner product, you know how to find norm. If you know how to what is the angle, all you need will be the concepts. And the other question is, all you need to know is what is a linear transformation, which you are going to study, because yesterday we did a thorough work on that. That's why I cannot say anything more than these word and this. If you seriously do this, if you seriously do this, you should get 100 out of 100. Believe me, I'm absolutely serious. 8 questions. That's basically it. If you have any questions, let me know. By the way, this Monday I will be very busy because there is the PhD qualifying exams at the Graduate Center, which I have to grade that day, and I will grade your exam this Sunday. So you will get back things Saturday, Sunday. But if you have any questions, feel free to email me. And in fact, if you have any questions, you said that you want to talk to me, definitely you can do that. Just email me. Okay?
Okay, thank you, Professor. Thank you, and see you next Thursday.
Yeah, see you Thursday. But listen, for Thursday, it's very important that you come, all of you come at 1:30. And you will get a note from me also. By the way, everything should be clear. Your audio, your video, and everything must be all set. Okay? Do not submit duplicates. Do not submit in at late. No, those things will not be accepted on the final exam.
Okay, thank you.
Very important, write your name on the first page because I will not see you after the final exam. So if you want your grade, please write your name on the first page because my plan, this is 17th, I want to post the grades on the 19th.
Oh, good.
Yeah.
Thank you.
Okay. Post the grades on the 19th. That means you go to CUNY first, you will get your grades there. Okay. Grades will be posted, so you automatically get it. Okay. Any
Okay,
questions?
thank you, Professor. Mhm.
Professor, I forgot to write my name on the exam too. Like that was.
That's okay, but